Physics fourth part about progressions or series. So we have three types of progression students. Already you studied this in 10th class, and ICSE students they studied all three, and CBS I think first and second. Now in this arithmetic progression, the numbers are arranged such that first number is A. Second number increases by some value, that is A plus D. Second number A plus 2D. Third number A plus 3D and so on. And the nth number will become A plus n minus 1 into D. That you know, the common difference, this is A plus 1D. Second term is A plus 1D. Third term is A plus 2D. Fourth term is A plus 3D. Nth term is A plus n minus 1 into D. So that's why this is also called nth number, nth term of arithmetic progression. Just like, let us say this is 2, 5, 8, 11 and so on. And in this you can see the difference between these two is 3. Difference between these three also 3. Difference between these three also 3. This is called common difference. So in arithmetic progression, it is a series with a common difference. Series of numbers or terms, with a common difference. So the common difference is due to the letter D. This is the difference you can see between these two common differences D, between these two common differences D, between these two common differences D. So here in this example common difference is 3. Now if you want to find out the nth term in this series, so nth term is given by here, the nth term is given by T, let us say first term, second term, third term, fourth term, I want the 10th term. So T10 is equal A plus n minus 1 into D, where A is the first term. Here in this first term is 2. I want 10th term. This is 10 minus 1 into common difference in this series is 3. So this is 2 plus 9 3s are 27, which is equal to 29. So the 10th term in this series will be 29. The second one, sum of n terms. How to find sum of n terms? Sum of n terms in arithmetic progression. Sum of n terms. Suppose if you are adding these three, you will get 5 to 10 plus 5, 15. But how to get the sum of the terms? Sn. Sum of n terms is n by 2. You know this formula. 2a plus n minus 1 into d. This is how you can find out the sum of n terms in this series. First formula is nth term. Second formula is sum of n terms. And the third formula is arithmetic mean of two terms. Arithmetic mean is A plus B by 2. Suppose if you take these two numbers, the arithmetic mean of these two numbers is given by 2 plus 5 by 2, which is equal to 3.5. This is about arithmetic progression. Now students, you know very well about geometric progression. Here, this is also series of numbers or terms. Series of numbers with a common ratio. The first term is A, second term is A into R, second term A R square, A R cube, and so on, A R power n minus 1. Just like here, first term is A, second term is 1 plus A plus 1D, third term is A plus 2D, fourth term is A plus 3D. So we need third term, this will become 2D, fourth term 3D. Similarly here also, first term is A, second term R power 1, For second term r power 1, third term r power 2, fourth term r power 3. So here nth term is equal to a into r power n minus 1. A into r power n minus 1 is the formula to find out the nth term in geometric progression. Now, how to get sum of n terms? Sum of n terms in GP. Sum of n terms in GP is given by mod first term into r power n minus 1 by r minus 1. When if r greater than 1 and r cannot be 1. R value should be greater than 1 and r value cannot. Suppose if r is equal to 1, 1 minus 1, 0, something by 0 will become infinity. So we cannot use that formula. This is this one. And one more point here we have to remember is sum of n terms can also be written as a by 1 minus r if r is lesser than 1. When r is lesser than 1, then we can use this formula, and this is very important formula to solve the problems in physics. Sum of n terms, first term by 1 minus r, then you will get sum of the infinite terms. Actually this is not n terms, sum of the infinite terms. Sum of the infinite terms is given by S infinite is equal a by 1 minus r if r is less than 1, and we are going to use this formula so many times in physics. The last one, harmonic progression, which is not required that much in physics, but still this is given by the first term is exactly opposite to the arithmetic progression, reciprocal of that one. First term is 1 by a, second term is 1 by a plus d, third term is 1 by 2d, fourth term n by 3d, and so on. The nth term is given by 1 by a plus n minus 1 into d. And one more here, geometric mean of two terms in AP is given by root AB, where A is the first term and B is the second term, or if you take a series of numbers like 1, 3, 9, 27, like this and so on. This is one series, and if you want to find out geometric mean of these two terms, this will become root 3 into 9, that is root 27. This is how you can find out the geometric term. So this is nth term only, and here this formula is enough, and mostly we will not use this formula in mathematics, very rare. Now we will see where we can use this concept of AP, arithmetic progression, and GP in geometric progression in physics. We will see now. In this case, students, I am writing a question here. A large number of tuning forks are arranged in order such that frequency of last fork is double to the first. So I have arranged so many tuning forks here. So those tuning forks are, this is first one, second one, third one, fourth one, and fifth one, last one. Frequency of the first fork is F. Frequency of the last fork is 2F. Now, the difference between the frequency of any tuning forks is let us say 10. Here in the questions of they are given, the difference between any two successive tuning forks is 10 Hz. find f. That is find frequency of the first tuning fork they are asking. Students, if you observe this one, the frequency of first one is f. What is the frequency of the second one? Frequency of second one is f plus 10. Third one is f plus 20. This one is f plus 30 and so on. So here a large number of tuning forks, and this number, it is not given in this question. If you observe this one, it is not given. First we will write what is the final number here. Nth term is going by a plus n minus 1 into d. The nth term is the final term. Here the final frequency 2f, the original frequency f plus n is not given, n minus 1 into d is equal to 10. And if you bring this one this side, 2f minus f is equal to n minus 1 into 10. So the frequency is equal to n minus 1 into 10. Generally when this problem is given, a large number of, let us say 20 tuning forks are given. Now what is f? So f is equal to 20 minus 1 into 10. This is 19 into 10. So the frequency of the first tuning fork is this will be 190 Hz. Here also we are using the concept of arithmetic progression in this problem. When the number of tuning forks are given, and by using this concept we can find out the frequency of first tuning fork. Then in the same problem, if they ask you to find out the frequency of the last tuning fork, it is exactly double to this one. That is 190 into 2. This is 380 Hz. This problem, already you know these resistors are connected in parallel. But the first resistors are second 2R, 4R, 8R, 16R and so on. The last resistor is infinity. I want to find out the resistance between these points A and B. To find out the resistance, students, this is a parallel combination. In parallel combination of resistors, we can write this as 1 by Rp. The formula is 1 by R1 plus 1 by R2 plus 1 by R3 and so on, 1 by that infinite. So this is 1 by Rp can be written as 1 by R1 is equal to first resistor R, second resistor 2R, third resistor 4R, next resistor 8R and so on to that infinite value. So 1 by Rp is equal to, if you take 1 by R common, students, you will get 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 up to infinite terms. So this is an infinite series. If you observe this one, this is GP only. The terms that are available here, these are GPs. Up to infinite, not 1 by infinite, students, up to infinite terms, because there are infinite resistors connected between A and B, between these two. So now from this we can write 1 by R in this GP, geometry progression. First we have to check whether it is geometry progression or not, GP. The first term is 1, common ratio. If you multiply 1 with half, 1 into half is half. Once again multiply with half, 1 by 4, 1 into 1 by 2. So common ratio is half, and from this we can say R is less than 1. So what is the sum of infinite terms in this GP? Sum of infinite terms is first term by 1 minus common ratio. So sum of the infinite series is, first term is A by 1 minus R is equal to 1 by 2. So S infinite is going by 1 by, this will become half. So I am writing this entire terms will become 1 by, this is 1 by 2. So from this we can write, this is 1 by R into, this 1 by 2 goes up 2 by 1. So now this is 1 by Rp students, but I need Rp, resistors in parallel, the total value of this parallel combination. 1 by Rp is 2 by R, Rp is equal to R by 2. This is the value, Rp is equal to R by 2. That is, sum of all the resistors will give 1 by 2 R or 0.5 R. Natural numbers. So we know natural numbers 1, 2, 3, 4 and so on. This natural numbers 1, 2, 3, 4, 5, 6, 7 and so on up to infinity. These are called natural numbers without 0 and without negative values. We are talking only about the natural numbers. Now what is the sum of n natural numbers? N is any number. First 10 natural numbers. Suppose if you add 1 to 10, then what is the value? Instead of adding 1 by 1 individually, we have a formula directly. Sum of n natural numbers. Here I am going to write 1 plus 2 plus 3 plus 4 plus and so on is given by this formula n into n plus 1 by 2. Suppose if I am asking you to find out sum of first 5 numbers 1, 2, 3, 4, 5. Without knowing that formula, we can find this value 5 plus 3, 9, 9 plus 3, 12, 12 plus 2, 14, 14, 1, 15. These are the sum of these 5 numbers. But with the formula, the last number is 5. That is, how many numbers are there? 5 numbers. Substitute this one. 5 into 5 plus 1 by 2. 5 for 6 are 30 by 2, which is equal to 15. So this is what we got there. But adding these 4, 5, 6 numbers or 10 numbers is very easy. But if they ask you to find out sum of the first 100 natural numbers, n is equal to 100, directly we can write yes, n is equal 100 into 101 by 2, 15. So this is 101 into 5 is 505, 100. So answer 5050. So by using this formula, students, it will become very easy for us to find out this sum of n natural numbers. Sum of n natural numbers, we can do it very easily. So for this, the formula is sum of first n natural numbers is n into n plus 1 by 2. Second one, sum of squares of first n natural numbers, that is 1 square plus 2 square plus 3 square plus 4 square and so on, n square. When squares are given, this will become n into n plus 1 into 2n plus 1 by 6. Let me take the same concept. N is equal to first 5 numbers. So sum of 1 square plus 2 square plus 3 square plus 4 square plus 5 square. Without finding these squares values, directly we can do it. Here last term is 5. So 5 into 6 into 5 plus 1 is 6. 5 2s are 10 plus 1, 11 by 6. 11 5s are 55. So this is without finding 5 square, 4 square, 3 square, 2 square, 1 value, directly we can find out this value. Suppose if you know, if you don't know this formula, then also you can check it. 1 plus 4 plus 9 plus 16 plus 25. This is 16 plus 4 is 20, 45 plus 10, 55. That is your answer. This is sum of n natural numbers. This is sum of squares of first n natural numbers. Now cubes of sum of cubes of first n natural numbers. So for this we can write 1 cube plus 2 cube plus 3 cube and so on. N cube is given by n into n plus 1 by 2 is that formula, but whole square. Please remember this difference. This is not cube, this is only square. Suppose if I am finding the simple one, 1 cube, 2 cube, up to 10 cube. Finding cubes is a lengthy process, but by using just this formula, we can solve this value. Here n is equal to 10. So 10 into 11 by 2 whole square. So 2 1 so 2 5 so. So this is 55 into 55. 55 into 55. 25, 25, 27, 275, 5, 12, 10. So this answer will be 3025. Based on these progressions, which term of the sequence 72, 70, 68, 66 will be 40? And first if you observe this one, the difference between these two is minus 2. Difference between these two is minus 2. Difference between these two is minus 2. So this is common difference, not common ratio. This is AP. So the given sequence is arithmetic progression. And in this, this is our first term. So A is equal to 72 and the common difference is minus 2. And I want the nth term which is equal to 40. I want the number of the term. Which term? Nth term. 4th or 5th or 7th of the options are 10th or 17 or 20 or 15 we will see. We know nth term is given by A plus n minus 1 into D must be equal to 40 according to the given data. And A is equal to 72 plus n is unknown to us. Common difference is minus 2 is equal to 40. 72 plus n minus 1 into minus 2 is 40 when it comes this side. Or you keep 40 here and remove this 72 and write here minus 72. This will become minus 2 into n minus 1 is equal to minus 32. Cancel this and this. 2 1s 2 16s. N minus 1 is equal to 16 and n is equal to 17. That means in this arithmetic progression, the 40 will be the 17th term. Option B is correct. Now, the next problem. How many terms are there in this AP? 7, 10, 30 and so on 43. So we need to find out the number of terms. Once again, please check it. But here checking is not required. They have mentioned this progression as AP. So in that the first term is equal to 7. The common difference is T2 minus T1 or any difference between any two successive numbers. This is 10 minus 7, 10 minus 7 which is equal to 3. And the last term in this series is 43. I want number of terms in this series. So here A plus n minus 1 into D is equal to 43 and A is equal to 7 plus n minus 1 into common difference is 3 is equal to 43. Take this and keep that side. N minus 1 into 3 is equal 43 minus 7. N minus 1 into 3 is equal 47, 43 minus 7 will become 36. 3 ones so 3 12s. N minus 1 is equal to 12. N is equal to 13. So that means in this given series, the total number of terms, if it is the first term, second term, third term, this will be the 13th term. Option A is correct. Now, third problem. Find the sum of the following arithmetic progressions. So these are APs only. In this AP, we need to find out the sum of the n terms. This is sum. So sum of n terms is given by total number of terms by 2 into first term plus last term. This is another formula which can also be written as n by 2 into A plus the last term in this series is a plus n minus 1 into d, or simply sum of n terms in AP is given by n by 2. A plus a is 2a plus n minus 1 into d. This is Sn. Now we can find out. Now in the first term Sn, I am solving this first problem now, students. So here in the first term Sn is equal to, how many terms are there? 12 terms by 2. And this is 2 times of a is equal to 1. This is 2 into 1 plus n minus 1, that is 12 minus 1 into d. If you observe this one, by adding 2 you will get this value. So common difference is 3 minus 1, which is equal to 2. This is a common difference is 2. So this will become 2 ones 2 6, 6 into 2 ones are 2 plus 12 minus 1 is 11, 11 2s are 22, 22 into 2, this is 24 into 6, 24 6, 6 4s 24, 6 2s are 12, 144. So answer for this one is, the first one is 144, 144. Similarly, the second problem, students, the first term is a plus b, second term is a minus b, third term is a minus 3b. So to solve this one, I am going to take first the same expression, same formula, sum of n terms in AP is given by n by 2 into 2a plus n minus 1 into d. This is n by 2 into 2a plus n minus 1 into d. Here, this is the first term, I will call this as a, but what is the difference between the two terms, common difference? Second term minus first term. So for this, common difference is T2 minus T1. T2 minus T1 is second term minus first term. Second term is A minus B. So I am finding common difference first. A minus B is the second term. Minus A plus B. Minus A plus B. So I am subtracting this. So signs will change. Minus B minus B. This becomes minus 2B. Plus a minus a get cancelled. So for every term we are adding minus 2b, minus 2b, minus 2b, minus 2b and so on. This will become 22 terms. This is 22 by 2, 2 into, first term is a plus b, 22 term minus 1 is 21 and common difference is minus 2b. So 2 ones, so 2 11s, this will become 11 into 2a plus 2b, students, minus 42b. So 2b minus 42b will become minus 40b. So this will become 11 into 2a, this is minus 40b. This is sum of these 22 terms for this AP. Now we see the next problem. Find arithmetic mean between 7 and 13. So arithmetic mean of two terms is a plus b by 2. So for this directly we can write 7 plus 13 by 2, that is 20 by 2, which is equal to 10. Second one, for this also we need to find out arithmetic mean. So to find this arithmetic mean for these two terms, first add these two terms. Arithmetic mean is a plus b by 2. So this is a, this is b. So I want to find out a plus b by 2. A is equal to x minus y, b is equal to x plus y by 2. So you can cancel plus y and minus y. This will become 2x by 2, which is equal to x. So this is a arithmetic mean of this one. Next one, find the common ratio in this one. When they are asking us to find out the common ratio, we know this is not AP, this is GP. common ratio is given by R is equal second term by first term or third term by second term or nth term by n minus 1th term. Any term by previous term. So here if you take this GP, so common ratio in this case is given by common ratio second term by first term, that is T2 by T1 is equal minus 2 by 4, 2 ones, 2 2's cancel, minus 1 by 2. So this is the answer for the first one. Now we see the common ratio for the second GP given here. For second GP, common ratio is given by, I am going to use the same formula, T2 by T1. Just divide this with this, that is 1 by 3 divided by 1 by 2, which means 1 by 3. This 1 by 2 when goes up will become 2 by 1. This is 2 by 3. That means if you multiply the first term with 2 by 3, you will get the second term.